Hello, dear students. How are you? Welcome to my channel, Physics Made Easy with Tawheed. The first topic today I am going to take, which is the hot topic for the Cbse physics examination this year. There are changes in the question paper pattern, as all of you are aware of. Case-based questions, assertion and reasoning questions have been included. So I am concentrating today on case-based challenges. First, my emphasis will be not on the questions, but all the type of questions that can be framed on the basis of a case study that I am going to take up first with you. I hope all of you will be traveling in this journey with me and understanding the basic concepts that how to deal with such questions when we are coming across case-based challenges. So, dear student, let us start case-based challenges. So, first thing, as you see on the screen, the name written is capacitors. Case-based challenges, right? All of you are familiar with this figure. If you are visiting some laboratories, that these parts are lying over there, these all are different types of capacitors. First, I would like to recall some basics of the capacitors for you, and these basics may form any paragraph, and on the basis of those paragraphs you may be posed some questions. So I have these collections of all capacitor basics over here, and then few questions based on that. We will try to answer all these questions on the basis of our study. So capacitor, as all of you know, is a passive device that stores energy in its electric field and returns energy to the circuit whenever required. So when a capacitor is connected to a circuit with direct current source, then two important processes, charging and discharging the capacitor, will happen in specific conditions. And a parallel plate capacitor, as you see in the figure on my right side, that it has two metallic plates and a finite distance is created between them with the help of some dielectric, so that, as you know, dielectrics are insulator, so that one plate does not come in contact with the other, and we can minimize the space as much as we can. As you see from the formula, C is equal to K epsilon naught A by D. This D is the separation between the plates, that if it is kept to the minimum, then capacitance with the same configuration can be increased, can be enhanced. So A is the area of the plate, as you know, separation between them, and K is the dielectric constant of the medium which is fit between them. Then the other basic equation for the capacitor is, that C is known as capacitance is the ratio of the charge given to it to the potential difference developed between the plates. So C is equal to Q upon V. Unit of capacitance is coulomb per volt, and it is called as farad collectively. When they are combined in series and parallel, then the formula is totally opposite to that of the resistances. If you remember that in series, the series resistances, you have R is equal to R1 plus R2 plus R3, but here you have 1 by C series equal to 1 by C1 plus 1 by C2, and so on up to 1 by Cn if n capacitors are connected in series. If n capacitors are connected in parallel, then this is C1 plus C2 plus Cn, which is once again opposite to that of the series parallel combination of the resistors. So what is the formula for series combination for resistor? This formula is here for parallel capacitors and vice versa. Energy is stored in a charge capacitors. Basic formula half CV square you can remember, and if we change with the help of this formula, as you see left side C is equal to Q by V, then we come across two other variants of this formula, half Q square by C, half QV. It means that this formula can be utilized when C and V are known, this can be utilized when charge and capacitances are known, and this can be utilized when charge and potentials are known. Then other important basics generally to which come to our mind whenever we name the capacitor, that the most common use for capacitor is the energy storage. However, capacitors are used in a wide range of industries and have become a vital part of everyday life because they are vital part of everyday life gadgets. On the simplest level, they are charged by current and then they release that current all at once. It means first they are charged and when the charge is required at once, then they release it. So this sounds to be very simple and it's not that much impressive that if you say it is charging and discharging. But if you just check a name of any device, like you see on the bottom, that flash on your mobile phone camera, turning dial on your radio, and loudspeakers and many type light sources, that this process is the main process which is creating all these functions in these devices. Then you see that this becomes the important process, the charging and discharging of a capacitor. So charging of a capacitor to store the charge, discharging means to release the charge. It means that charged by a current and when it is discharged, it is releasing the current over there. Then how does a capacitor work? You see in the circuit diagram, a capacitor has been shown connected with some resistances and a source of DC is applied across it. So when the voltage is applied across the terminals of this capacitor, then current start to flow and continues. This is the important part, until the voltage across both plates becomes equal to the voltage of the source. It means if you have applied 10 volt, then potential difference between the capacitor plates, if it becomes 10 volt, then process of charging will stop, and this takes a fractions of seconds. It's very uh, you can say the process takes place in a nutshell. It doesn't take much time. So these two plates are separated by dielectric material, mica, paper, glass. These all are example of the dielectric substances, and dielectrics, you know that this is the other name for the insulators. So dielectric increases the capacitance of the capacitor. You have seen in the formula, C is equal to K epsilon naught A by D. So we can increase the capacitance with the help of that formula also. Now, during charging process, how does the charging process will take place? This has been shown with the help of graph. All of you are able to see that it takes some time to get charged, but this time is, you see, is in the fractions of seconds. All right, and voltage across the capacitor is also shown over here. So, as soon as the switch is closed in position 1, you see that this is the position 1 and then position 2, then connected across the capacitor, current flows and the potential difference across the capacitor begins to rise. But as more and more charge builds up on the capacitor plates, the current and the rate of rise of potential difference both fall, as you see in the graph, and finally no further current will flow when the potential difference across the capacitor equals that of the supply voltage. As we discussed earlier, that when this potential difference across the plates becomes equal to the applied potential difference, then it is it stops the process of charging and it means that capacitor is fully charged. Discharging process, you see that the same circuit has been used. Now instead of using this plug, this is connected with number 2 and this is a resistor. So now capacitor is connected with the resistor. So as soon as the switch is put in a position 2, large current flows start to flow and the potential difference across the capacitor drops. As charge flows from one plate to the other through the resistor, the charge is neutralized and so the current falls and the rate of decrease of potential difference also falls. So finally, the charge on the plates is zero and the current and potential differences are also zero and the capacitor is fully discharged. The value of resistor does not affect the final potential difference across the capacitor. This is only the time that it takes to reach that value. So it affects the time constant, the resistance connected over here. Cameras and flashlight are using cameras touch screen is made up of all capacitor. That's why it is also called capacitive touch screen, and in the flashlight also capacitors are used. Now you see that you have come across all the basics of the capacitors, and you have revised all the things related to the capacitors. So anything can be given in the form of a paragraph in examination as a case-based challenge, and then you may be asked this question. That capacitor A has charge Q on it. This is the capacitor A, name is not written here, and capacitor B on my right, name is once again not printed here, but you can take the first one as A, second one as B. So when the switch is on, the charge on B will be how much? So charge on the B, I have put these answers in below the correct answer, that this will be 0, because these charges in the capacitors are the bound charges. They will not move unless the circuit is completed. So since the answer you can see on your screen, that since the positively charged plate is not connected to the other plate of B, negative charge on the plate of capacitor A is bound, hence no charge will be transferred. Now the second question can be asked on your previous study, that a parallel plate capacitor of capacitance C is charged with a battery of EMF V. After the capacitor is charged, the battery is removed and the distance between the plates is doubled, and the new energy stored will be how much? So you see that distance between the plate is doubled. Distance between the plate is a small d. A small d is doubled and capacitor is charged, battery is removed, then what will be the new energy stored in this? So if you remember these factors, you can see that when the battery remain connected, so charge will remain same as it is conserved. So therefore CV is equal to C dash V dash. C dash V dash is the new charge. It means that new capacitance will become C by 2. So capacitance will become half. If you put this formula in these formulas, half CV square, all these values, then you see that answer is coming CV square. So CV square is the right option, as you see in the previous slide, that this is the right answer. Now the camera flash requires, question number 3, 6 microfarad and 3 capacitors 4 microfarad each are to be connected. It means with the help of 4 microfarad you have to obtain 6 microfarad. So what will be the best way to connect them? Then obviously this is some mathematical question. You know that 2 should be connected in series, 1 in parallel, as I have shown you in the solution, that 2 are connected in series, and whatever answer comes for that, that will be in parallel to this one. So 4 and 4 in series, answer is 2. And when 2 and 4, sorry, are connected in parallel, then answer is 6 microfarad. So this is the way that 2 in series, 1 in parallel will give you 6 microfarad. Okay, so D option is correct. Now the fourth question is that the amount of heat generated when switch S is shifted from position 1 to 2. From position 1. When it is in position 1, what do you find, the students? That both the batteries are there and both the batteries are in opposition to each other. I means V1 and V2. Positive is connected with positive. It means that net potential difference applied by these two will be V1 minus V2 or V2 minus V1, whichever is greater. So V1 minus V2 is connected to C. Now after that they are saying it shifted from 1 to 2. So when it will be shifted from 1 to 2, you see that source V2 will be out and only V1 will be there. And then now this V1 will be charging the capacitor C. Keep this in mind and then you see the solution, that initial charge on the capacitor C will be Q C into V, and V, I have told you that this will be the difference of the two because cells are in a position. So when the switch position is changed from 1 to 2, then charge on the same plate will become, for example, Q dash, then this will be only CV1 because only V1 battery is there. If we take the difference of these two charges, Q and Q dash, one factor will be cancelled as you see, then this will become CV2. Alright, work done formula Q minus Q dash V, and I hope that you remember this equation, first law of thermodynamics, delta H is equal to delta U plus W. And if you substitute all these values in this formula, then you find final answer CV2 square by 2. Right? So this is the solution, CV2 square by 2. This is the final answer for this question. Now the last question on the basis of this, you see, of partly you already answered for this the previous question. A camera flash circuit uses three capacitors of 4 microfarad each, such that net capacitance is 6 microfarad and a 10-volt battery. Then energy released as the flash is used is will be how much? As you see, half CV square. So C is given 6, V square will be 100, 100 into 6 divided by 2, 600 by 2 will be 300, and unit will be, because this is microfarad we have not converted, so answer will be in microjoule. So 300 microjoule will be the correct answer. You see that one answer is given 300 joule also. So you have to be cautious about the unit, that this will be the 300 microjoule. I hope you must have enjoyed this case-based study challenge capacitor. All the best. Thank you.